So this is the last sample problem for this week. We're also going to apply the conservation of mechanical energy. I'll call it like a roller coaster style problem, but it's not really a roller coaster. It's a more ideal situation where we have a frictionless track. That's really hard for a roller coaster to do. So we'll just call this a frictionless track. It says we have an object sliding along a frictionless track as shown. At point A, the object has a speed of 4.0 meters per second and a height of 6.0 meters above the ground. When the object reaches point B, which is 2.0 meters above the ground, what will its speed be? The first thing we need to do, since we are going to be talking about gravitational potential energy at some point, we have to decide on what the reference height is going to be for this problem. We can choose any reference height we want. So you could choose the ground as a reference height if you wish, because two numbers are given in the question that says how high points A and B are compared to the ground. However, what I'm going to do is something I think is going to make things a little bit simpler actually, and that's to choose point B, or however high point B is, that's going to be my reference height. Okay, so by doing that, that means the height at point B is 0. And that's going to let me cancel out something in my equation. Okay, so that's what I'll choose for my reference height. In terms of solving this, once again, it's the conservation of mechanical energy. So ME1 equals ME2, or K1 plus U1 equals K2 plus U2. And I'm going to list out some variables with subscripts of 1 and 2. So I'll start at point A. The question says at point A, the object has a speed of 4 meters per second. So I'll say V1 equals 4.0 meters per second. The height at point A, so H1, how high is that compared to the reference height? Okay, so I do have to look at my numbers closely. I have 6 meter height above the ground, and then point B is 2 meters above the ground. So the difference there is 4 meters. There's a lot of 4s in this question. All right, so V1 is 4 meters per second and H1 is 4 meters. In terms of point B, we need to find the speed of the object at point B. So V2 is a question mark. And the height at point B is 0 meters, because that's where I set the reference height to be. That's why I did that, so that I can have a 0 in my list. So with that being 0, H2 being 0, that's going to allow me to cross off U2. Okay, so if the height at point 2 is 0, then the gravitational potential energy at point 2 is also 0. That's the only 0 that we have. Okay, so the rest of the equation, we're going to convert the k's into the formulas for kinetic energy, which is half mv squared, and convert the u's to the formula for gravitational potential energy, which is mgh. Do that to both sides. All right, so that's what the equation looks like. And then what I'm going to do right away this time is cancel out all of the m's, or in other words, divide both sides by m. I see that every single term, so there's 3 terms in this equation, all 3 of them have m in it. So that allows me to divide m by both sides, which will essentially just eliminate all the m's. Once again, that's a good thing, because The mass of this object was never given in the problem, so it better cancel out in the math. Okay, what are we solving for here? I look back up and I see the question mark in my list. We are trying to solve for V2. Trying to solve for V2. So it looks like what I'll have to do is multiply both sides by 2 to deal with the half there, and then square root both sides. I'll do it one step at a time. Okay, multiply both sides by 2. So 2 times a half cancels out, and I have v1 squared left here for the first term. And then this will be 2 times g h1, and then equals on the right side. 2 times half cancels out, leaving me with v2 squared. Okay, so my first step was multiplying both sides by 2. And then I'm going to square root both sides. And that's it. I'll fill in the values and then I'll be done with it. So I'm going to move over to the right hand side where I have some room. I'm going to write v2 equals the square root, and I'll fill in the values. So v1 squared is 4.0 squared, and then plus 2, g is 9.8, and h1 is 4.0. And I'll get that in the calculator. So I'm getting 9.7. So that will be the speed of this object when it reaches point B. The number is higher than 4. That makes sense. It's going to be faster than 4 meters per second. It's quite a bit faster, actually. Yeah, it did drop quite a bit in height. It dropped 4 meters in height. So that should allow it to pick up quite a bit of speed there. All right, so then you can practice some of these mechanical energy questions on your own. And there's no problem set this week. So just do the questions. You can turn them in to try to get some feedback so that you're ready for next week's problem set.